Good afternoon. Would you students please sign in on your attendance board?
Think of a reason why your cells do not stop growing when you are fully grown.
So this is just something that we're going to think about today while we're going through the lesson, and I wanted to ask you guys, think of some reasons why your cells do not stop growing when you're fully grown. And Haley, would you like to explain your answer?
I said because cells have a shorter life than people, so when they need to be replaced, they never stop growing.
And Russell?
Pretty much the same thing. It's just when cells die, they need to be replaced, and so we have to keep growing them to be alive.
And Cecilia?
We're always constantly nourishing our body. We're always feeding it, so the cells will always stay alive.
Excellent. So today, just keep those things in mind, and we're going to talk a little bit about your cells and growing and replacing cells and replenishing. So what is on our agenda for today? You've already signed into the smartboard. We're going to talk a little bit, an introduction about the topics and regeneration, cell reproduction, and mitosis. We're going to watch a short video on what is cancer, and then we're going to play a regeneration game. So what are we going to learn today? You're going to learn what cell regeneration is and some examples. You're going to learn what mitosis is, how fast cells divide, and you're going to learn what cancer is. Has anybody heard of regeneration before?
Yeah.
Regeneration is the ability to recreate lost or damaged tissues, organs, and limbs. So Cecilia, would you like to explain that to the class?
Our tissues, even if they die, there's something that's going to replace it.
Excellent. So does anyone know what happens to the tail of a lizard if they get their tail cut off in a fight with a predator?
It'll regrow eventually.
Exactly. So what can happen is that their tail will regrow, and this is an example of regeneration. The lizard gets into a fight, and the tail regrows. So what happens if you cut, if you have a plant, sorry guys. So if you have a plant here, and you cut it right here in the stem, you take the roots, and then you take the leaves, and you put them into parts of water. Does anybody know what will happen?
It'll regrow.
What will regrow?
Well, if you place the roots in water, the stem will regrow. If you place the stem in water, the roots will regrow.
Excellent. And what is this example of?
Regeneration.
Regeneration. Haley, do you remember what regeneration is?
Isn't that when cells replace themselves and or grow from old existing cells?
Excellent. Okay, so how does one cell become two cells? In the process of regeneration, basically the cells are rebuilding, regrowing, and they're dividing. So we start from one cell, and then that cell will divide into two cells, and from that cell, two more cells. And that is what's known as mitosis. So what happens when, in mitosis, is the chromosomes in the cell, and Does anyone remember what chromosomes are?
DNA.
The DNA? Excellent. So the DNA that's inside the cells, what will happen with, it will duplicate itself. So it will copy itself and make two complete identical sets. So that when cells split, each cell has an exact copy of the same set of DNA. And there's a picture of a chromosome there. So how fast do cells divide? Does anyone have any idea? Fast, slow,
Rapid?
rapid, how rapid?
I don't know.
Well, every different kind of cell has its own life length. A bacteria, which replicates really fast, can replicate a cell in about 20 minutes. A frog embryo, about an hour. Intestinal cells, about 2 days. And liver cells, 200 days. And we know that cell division is important for growth and repair. So, does anyone know what happens if cells multiply and spread uncontrollably? We want cells to multiply, but there has to be a level of how much we want them to multiply.
Like a control level?
Yes. Watch a video.
Cancer is a group of over 100 diseases characterized by abnormal, uncontrolled cell growth. In a healthy body, cells grow, die, and are replaced in a very controlled way. Damage or change in the genetic material of cells by environmental or internal factors sometimes results in cells that do not die and continue to multiply until a mass of cancer cells or a tumor develops. Most cancer-related deaths are due to metastasis, malignant cells that penetrate into the circulatory system and establish colonies in other parts of the body. Great advancements have been made, but cancer is still the leading cause of death for people under the age of 85. In the United States, 1 in every 4 people die from cancer.
Okay, so what did you guys take out of that video? What is cancer?
An uncontrolled growth of cells.
Is it unwanted cells?
It's when the cells, they grow too much, right? We talked about regeneration and how we want the cells to regrow and replace themselves for growing and repairing things. But what happens with cancer is that reproduction can't be controlled. So the cells grow so much and they start growing into tumors and overgrow, and that's bad for us. So we're just going to recap here before we move on. The 3 major topics we talked today was regeneration, mitosis, and cancer. So, does anyone remember what mitosis involves?
Cell division?
Yes.
Duplication of DNA.
Yes, excellent. And what are some examples of regeneration?
When a lizard's tail regrows.
Excellent. And when does cancer happen, Cecilia?
It can happen at any time when you have lots of cell divisions. That's not controlled.
Excellent. So now we're going to play a little game. Okay, so this is the regeneration game. And how you play this game is I'm going to ask you to come up one at a time, and you're going to see which one of these you think involves regeneration and which one of these do not involve regeneration. So Haley, you can come up first.
Okay. So what am I doing? Which involves regeneration?
Which involves regeneration?
And which does not?
Yes.
So do I just do one of each? Or
One of each, yes.
one of each? Okay. I'm not quite sure about these, like, inanimate objects, but...
Russell? can you please put up 2 more?
And finish it off.
Yes,
And it looks like they all regenerate, so we're just gonna put them all up there. Oh, do cells regenerate? I think so.
Okay, let's check your answers. So it looks like you guys have gotten them all right. So these ones here which don't regenerate, why don't these regenerate?
Because they're not living things.
That's just the answer I was looking for, Haley. Thank you. And in these cases that we have right here, who put this one up? The girl with the
I
first
did.
knee. Explain how that's regeneration.
Well, when you scrape your knee, your skin has to regenerate itself right after it scabs.
And what happens when you cut yourself? It heals, right?
Yes.
Excellent. What about here, Haley?
Same sort of idea, but with bone instead of skin.
Now, Russell, can you explain the regeneration in this? It's a growing fetus developing.
Well, it's the cells and in the fetus that are multiplying and generating new tissue.
So the cells are growing, right?
Yep.
The lizard, we talked about the lizard, right? The tail will regrow in a lizard. What about this one here? A plant's growing. The plant wasn't injured. It doesn't have a cut, a scrape, or a bruise to regenerate. So how is that regeneration in the plant, growing plant?
It regenerates because it always builds up new sprouts. It's growing.
Excellent. So regeneration is repairing, but also growth as well. Those are the things we have to remember. Chromosomes are involved in, what are chromosomes involved in?
Cell division.
And what happens in cell division?
Make 2 new cells.
Cells divide, right? And the chromosomes split and duplicate? Excellent. And here we talked about if you split the plant stem cell into 2, it will regrow. And a heart. Haley, would you like to explain regeneration in the heart? It's a tricky one.
Yeah, it is.
Anyone else have an idea?
Well, the cells in the heart die and are replaced just like the cells in any other part of the body. So it's constantly regenerating new cellular mass.
Excellent. So the point here is that everything living has regeneration because cells are consistently dying and consistently need to be replaced. So whether it's something that's growing, something that's damaged, or just any organ, the cells are consistently being replaced.
Miss Angela,
Yes.
are pacemaker cells renewable?
Pacemaker cells? Yes.
Okay.
All cells.
Cool.
Any other questions? If it's a living cell, they regenerate and replace. Any questions? Thank you, everybody. It's recess time now.
Teacher of the Year.
How long is